So hey everyone, welcome back to my channel. So today I'm going to do an internship task. So currently I'm doing my internship in Oasis Infobyte company. The link for doing this virtual internship program will be in my description box. So this internship task is about iris classification. So the problem statement is to classify iris flower according to the species. So I had written the code as it is. So first let's study the data. What's the data is? It's having ID, sepal length centimeter, sepal width in centimeter, petal length in centimeter, petal width in centimeter, and according to that properties or features, species is provided. So we have to study on the basis of that, and we have to classify iris flower according to the species. So for any data science task or any data science project, we have to move forward onto the task or steps or process, that is data gathering. So here we are already having the data, that is iris.csv. So this is the data I'm having. After data gathering, there is a process having called data cleaning. So in that data cleaning, there are many conditions we have to follow that. For example, we have to handle missing values. After missing values, we have to go for removing duplicate records. Then we have to detect outliers if any, and if there, we have to remove or treat that outliers, how we have to transform that outliers or not. And last, we have to correct inconsistent data in data cleaning part. Then we have to data transform, where it's having feature scaling, feature encoding, feature engineering, dimensionality reduction. Then data integration, we have to combine data from multiple sources. Then the data reduction, we have to reduce the data set if necessary. Then data normalization for efficiency and accuracy, data splitting for model training, testing, validation, and all. Data visualization to do a data analysis or explorative data analysis. And last, we have to keep the documentation if someone is handling that project, so that they could also be understand the project like what we are doing, so that they can handle the project for the continuation process. So this is just a markdown cell. Now first, we will import the libraries needed to load the dataset. So for importing the libraries, for loading the dataset, we will import pandas as PD. I'll choose the environment. Yeah. So it's loading. Import pandas as PD, and it's this cell has been run. Now I will putting the data frame as df and storing the data as iris.csv in data frame df. Same data frame is loaded now. Now we will check some information or some key values or key information what we will be getting. So here we can see that there is one ID which is having a int data type, and rest four features is float and species or target variable is having object data type, and there are no null values, I think so, no. So if we will describe the data frame, so in that sepal length there is the average values of 5.8. Sepal width is having a 3.05. Petal length is having 3.75 and petal width is having 1.19. And some values like minimum value, max value, 25%, 50%, 70% is standard deviation in the f.describe part. Now checking the missing values if any. So there are no missing values. So as there are no missing values, so we can move forward to the duplicate values. If there are duplicate, we can remove it. If the duplicates are under 5% of the data set, because if there are more than 5%, we cannot say that the data of duplicates can be removed or not. So uh, yeah, there are no duplicates, so we can leave as it is. So as there are no duplicates, we can move forward to outlier detection and transformation. So for the outlier detection, we will go forward for a visualization called cbon. Is a library for visualization purposes. So I had called a box plot diagram to check the outliers is present or not. And to check that outliers is present or not, we are seeing that outliers is present in sepal with centimeter. See, these data points are there. These data points are showing that this feature is having outliers. So this feature is having outlier. As there are outliers in one feature, we will move forward to the outlier transformation because clustering are sensitive to outliers. We cannot remove also, but we have to transform that outlier itself. So now we will check the distribution first. How is the distribution? And on the basis of that, we can transform if it's a right skewed or left skewed or normal distribution. If it's normal distribution, we can leave it. But if it's a right skewed, we have to go on to the transformation for outlier. So we are seeing it's bell shaped, so we can say that it's a normal distribution only. So we can move on forward onto the Winsorizing. So what is a Winsorization? I just go on to the part Winsorization outline so that if I say wrong, you cannot blame me. So Winsorization is the transformation of statistics by limiting extreme values in the statistical data due to reduce the effect of possibly spurious outliers, which means that we have to just transform the outliers and it will transform the outliers in such a way that the outliers will not be seen and we can make our data more redundancy. So this is the distribution. So I just use Winsorization method to limit the data. Here I used a SciPy stats and in that I used mesh stats where I had used the Winsorization method of the data frame only settle with centimeter and with limits. Now I'm going to check the distribution again so that I will see that the distribution or outlier is there or not after visualization. So there is no outlier. Here we are seeing that the outliers was there in sepal with centimeter. Now in the sepal with centimeter there are no outliers. The sepal with centimeter there are no outliers. So as outliers are removed from the data is now completely pre-processed. So we can proceed with the classification or clustering method. So finding the K cluster for K means classification. So for the clusters, how many clusters we want is the more and first most important part so that the clusters should be there according to the properties we are classifying. So we are just taken the x variable in that 0, 1, 2, 3 means sepal width, petal width, then sepal length and petal length. These four features we are taking as in x variable, and now we will import a k-means package for clustering. So for that we will import from the sklearn cluster import k-means and matplotlib for some graph. So this is WCSS. So what does WCSS means? Uh, so WCSS is in the k-means where we will see that how much clustering or how much clusters we want. So WCSS is just the full form within cluster sums of square. So it just says that how much clusters we want for our data set. So we are keeping as an empty list and we are running a loop in 1 to 11 that from 1 to 11 how much clusters we can make according to the elbow method. So we had run here the k-means package. K-means function in the n clusters is in I, which is in for loop. Init is k-means plus plus. Max iteration would be 300 and initialization is 10 and a random state we are taking as 0. So we will fit the function or fit the clustering method k-means in x that is our features and that we will append in the WCSS list that is within clusters of some of squares. and we will plot the data frame and we will plot the data frame. No, we will plot the clusters on the basis of the elbow method. So according to the elbow method, we are seeing that from yeah, this is the main thing. We can see that the elbow method graph is changing. So we can consider this as 3 because 2, 3, 4. Yes, 3. So we will requiring 3 clusters for our data set. And if the data set is 3, if the cluster is 3, so form our clustering. We will form our clustering and we will fit the prediction. We will fit the remaining data set, and this we had fit in the y k-means. Now we will create a cluster on the basis of that with a centroid k-means clustering, and this we form our cluster where red is specifying that this is iris certosa, where blue is specifying that this is iris versus color, and green is specifying the iris virginica, and yellow color is the center of the cluster. This is the cluster, and in that centroid is yellow one. And here we classify the clusters as the iris species according to the features of the flower. So this was my first internship task, that is iris classification of Oasis Infobyte. Mm, yeah. So this was my task one for iris flower classification, and we had done the task, and it's been uploaded in the GitHub also. So for the GitHub link, you can check in my description box. So this is for my task one, and we will proceed to the task two in the next video. So thanks for now.